I am looking at Keeper 6.6a, and we're just going to hit just one more time a few of the things that you need to keep in mind and remember for the STAR test. Okay, so if I'm looking at the periodic table, please remember that most of the elements on the periodic table are metals, and that metals are generally on the left-hand side of this stair-step line. So you've got metals, which make up most of the periodic table. Along the staircase or zigzag, you have metalloids. Remember, metalloids have properties of both metals and nonmetals. And then on the right-hand side, you have nonmetals. You have one nonmetal over here, and that's hydrogen, but it's placed over there because it has one valence electron, which makes it chemically similar to those alkali metals, which are in that first column. Okay, just remember to go back over your properties of metals. They're shiny, good conductors of heat and electricity. You can hammer them into sheets, pull them into wires. Most of them are solid at normal room temperature, whereas nonmetals, a lot of them are gases at room temperature. They're dull and brittle if they're solid. They don't conduct electricity or heat well. Many are gases, and of course they're found on the right-hand side of the periodic table. That little blurb should help you with the first couple of questions on your one last time Google form. And then we're going to go on to the next sheet you need to glance at. I'm now looking at 6.6b, one of your pink Keeper sheets. Remember that density is the amount of mass in a certain volume. Kind of measures how compact something is. Your formula, mass divided by volume. Okay, this is how you calculate density. You find the object's mass, typically in grams, divided by the volume, and the volume will either be given in milliliters or in cubic centimeters. By the way, if you see a number with cm with a little 3 after it, you don't do anything mathematically with that little 3. That's just part of the unit to show you that it's volume. On the STAR test, you will be given a formula chart, whether you have it on paper or as one of the online supports. You will have a formula chart to look at. Density is one of the formulas that they give you. It's mass divided by volume. I don't know if you guys have seen the little triangle where you kind of do like this. Density is mass divided by volume. Usually they just ask you to calculate density, but if for some reason you needed volume, you'd just cover it up and it would be mass divided by density. If you needed to find mass, you cover it up and it would be density times volume. Okay, I'm now looking at Keeper 6.5c. And I'm just going to point out one or two things that you've absolutely got to know. You have to know your 3 subatomic particles. These are the small particles that make up atoms: protons, neutrons, and electrons. You have to know that protons are found in the nucleus, that they have a positive charge, and they have a mass of 1 AMU. Neutrons, also found in the nucleus, they have no charge, or they are neutral, and they also have a mass of 1 AMU. And then the electrons are found in the electron cloud. They have a negative charge, and they have almost no mass. All right, now let's talk about mass of an atom. The mass of an atom, you'll need to know protons plus neutrons. You don't consider electrons in the mass because they have almost no mass. Okay. The other thing that you could do is let me see. Let me go to the ape man. Okay, so yes, mass is the number of protons and neutrons together. Again, don't count electrons. But what if you're just looking at a box from the periodic table, like this? Okay, remember that the smaller whole number is the atomic number, and then this number, in this case 18.998, that's the atomic mass. In order to deal with it, you must round it off. Okay, when you round it off, that becomes the mass number, and it really is the mass number of what fluorine is most of the time, but not absolutely all of the time. So I would round that off to the nearest whole number, which is 19. And if I was given the box on the periodic table and had to come up with mass or neutrons or whatever, they're related this way. I can take the mass number, subtract the atomic number, which is the same as the number of protons. Remember, atomic number and protons are the same thing. Mass number minus atomic number gives me neutrons. Or, if for some reason I had the mass number and the number of neutrons, I could find the number of protons, or what have you, okay? But protons plus neutrons is going to give you mass number. And if you have to pull a mass number from the periodic table, please make sure to round it off. Okay, and I'm going to say one more thing about this. Atomic number is always equal to the number of protons. Okay, so protons and atomic number are always the same. If the atom is neutral, then that also equals the number of electrons, but that's not always the case. Remember, in chemical reactions, electrons are gained or lost, so we don't always have the same number of electrons. If it's neutral, then that's true, but it's not always true because atoms aren't always neutral. But atomic number is always equal to the number of protons. Okay, this is a copy of the reference materials that you will either be given on paper or that will be available online. And again, they give you an example from the periodic table and they remind you that this is atomic number and that this is atomic mass. Remember that the mass must be rounded off to use it. Okay, but don't panic. There's an example. It's just they're not going to tell you that atomic number and protons are the same. You're supposed to know that. Okay, next, one last reminder about valence electrons. I am on your pink sheet, 8.5 ABC, down towards the bottom where it talks about electrons. Electrons in an atom's outermost energy level are valence electrons. Valence electrons are the ones that determine an atom's chemical behavior or chemical reactivity. In other words, the number of valence electrons is going to determine whether an atom will form chemical bonds. Okay? Valence electrons are the only electrons involved in chemical bonding. Now, the number of valence electrons is only the electrons in the outermost energy level. Okay? Your first energy level, remember, can hold 2 electrons. Second energy level can hold up to 8. Third energy level can hold up to 8. But if an atom has 3 energy levels, then only the electrons in that third energy level are considered valence electrons. So valence electrons, remember, are only the electrons in the outermost energy level. Okay. For instance, sodium has a total of 11 electrons if it's neutral. 2 of them are in the first energy level, 8 are in the second energy level, and only 1 electron is in the third energy level. So it only has 1 valence electron. Okay? Valence electrons are the ones in the outermost energy level, and they are responsible for chemical bonding. All right, this is a quick reminder about the layout of the periodic table. All of your elements in this first column have 1 valence electron. Hydrogen is put there because even though it's a nonmetal, it has 1 valence electron. All of your elements in the second tall column have 2 valence electrons. As 8th graders, you don't have to worry about figuring out how many valence electrons there are in these short columns. But you go back over here to the tall column, next tall column, that's either column 13 or 3A. There are 3 valence electrons for everybody in there, 4 valence electrons, 5 valence electrons, 6 valence electrons in column 16 or 6A, 7 valence electrons for the halogens in column 17 or 7A, and then 8 valence electrons for our noble gases except for helium. Helium only has 2 valence electrons, but it's placed there because it's full with 2 valence electrons because it only uses 1 energy level. Okay? And things that are in the same column have the same number of valence electrons, and therefore they have similar chemical properties. Okay? elements in the same row are using the same number of rings. Think row and rings, same number of energy levels. So hydrogen and helium are only using 1 energy level for their electrons. Everybody in row 2 is using 2 energy levels, so on and so forth. I'm now on the back of 8.5D. Remember that a chemical formula uses coefficients, which are the big numbers in front of the whole formula, subscripts, which are the small numbers down to the lower right, and chemical symbols to determine the number and type of different elements in a compound. So here's your example. You had a big 3 and then it says CH4. That means that there are 3 molecules of CH4, and CH4 is methane. Okay? There's no subscript on carbon, but if there's no subscript, we understand that there's 1. This subscript on hydrogen is 4. Okay? And just real quickly, if you have parentheses, remember that, for instance, in here, phosphorus inside has a subscript of 1, but then you have to multiply by the subscript outside, which is 2. So 1 times 2, and then since there are 4 molecules, you multiply by 4. 1 times 2 times 4 to get a total of 8 phosphorus atoms. Oxygen has a subscript of 4 inside, times 2, and then times 4 atoms, 4 molecules. 4 times 2 times 4, that's 32 oxygens. This 3 goes with calcium, because remember the subscript's always to the lower right. This 2 does not apply to the calcium, it only applies to what's in the parentheses. So calcium is 3 times 4, there's a total of 12. At this point, I want you to go do the first section of the Google form and then join me for the next quick review.